So I believe this is where we had left off with yesterday. Okay. And as we can see, why is it that it's more difficult to come up with isomers for alkenes as opposed to alkanes? Yeah, because of that double bond. Because with alkanes, you just pull a methyl group or an ethyl group off. In this case, you can do that as well, but you rotate the bond as well. Okay? And that's what we're talking about here. Butene has three structures, two isomers. Butane only has the one structure and the one isomer. Okay? And the content that we will go over, we're going to see it over and over, and it is difficult to maybe understand, but we're here to navigate you through that process. Okay? As long as you ladies don't give up on yourself or throw in the towel, there's no reason that we would on our end. If we're struggling with this, it's take that initiative, come in, talk to myself, and we'll get you straightened out. Okay, and at this point, there's really no, what I want to say, concerns that I have. You might be looking at your grades now. My grade isn't what I would like it to be, but how many times have we said, cut yourself some slack? This is a really difficult class. Okay, with that, again, it's our job to navigate you through this. Moving forward. Okay, no surprise here. You're just changing that suffix when you're talking about what we were referring to, butane and butene. You see the suffix ene, you know you've got a double bond someplace. So, just out of curiosity, are you working on a trailer in a class? Does that sound right?
We have a go-kart that we're working on the engine.
Okay.
They brought the paper shredder and they will take the engine off it and put it on.
So have you had to use a torch for any reason to cut through any metal or anything like that?
No, I've been there.
Okay. And you're not always necessarily cutting things to be using this torch. I've seen this before as well, and it's actually pretty radical. Is let's say you have a rusted out bolt and nut. Okay, you can't turn it. You take that cutting torch and you heat that up. You heat that bolt up, that hex, or excuse me, that hex nut. You heat it up, heat it up, heat it up. You don't melt it, but just from what you know about them, what happens to objects when they heat up, whether it's a gas or a solid, what are the molecules and particles going to start to do? They're going to move, but more importantly, do what? Especially with gases, what do we know? What do they do when they get warm? They contract or expand. Yeah, they'll expand. And the tricky part about that is if you're expanding that hex nut, are you doing that same to the bolt? Well, not as much because that's insulated by that hex nut. So then you heat it up enough, then you can take that rusty old hex nut off and it works that way. The reason I bring that up is working in a shop, you have two gas tanks on that cutting torch. One is oxygen, no surprise there. But the other one is ethine, is the scientific name, but acetylene is the more common name. Just like what we see here. People aren't going to say we've got an oxygen ethine torch. They don't say that. They've got an oxygen acetylene torch. In this case, ethylene is the scientific name for what you have in front of you. Yes, it's plexiglass, but it's also a form of what do you think? Something that doesn't degrade. to form a plastic. Okay, so this is plastic. This is known as xylene, which is a type of styrofoam. So you don't usually use those types of names, ethylene and propylene. You either might say plastic or xylene. Okay, those would be their common names. Okay, and then let's see here. I wanted to maybe we'll save that for tomorrow. We'll just go over those examples on the board. See, told you I didn't have a whole lot for you today. Kind of a relief in that matter, maybe. So let's just go ahead and we're done with this note taking. I've got some examples behind here, and then we'll go over those, and then we'll stop there for today. All right. So if you choose to write this down, okay, it is for your benefit, okay? And as you're looking up there, I would bet it probably looks kind of confusing. And no one's going to argue with you and say, oh, geez, that's really easy. Well, maybe yes, maybe no for some people. And one of the reasons we're approaching it this way is I think when we see the examples and work through them, then read through the content, I think we will be better off for that. Because I don't know if it helped you when we read the rules for naming alkenes. I think it's just easier to just do the process and then go through and say, okay, this is what we're doing. This is why. This is the rationale. We got it alphabetized. We got to disregard prefixes except for the letter I in isobutyl and isopropyl, which only one of these compounds actually has derivatives on it. The other four, okay, 1, 2, 3, actually does not have any derivatives. All the carbons are part of the parent chain. So that's what we'll be going over here shortly. Yes. Okay, if we can proceed, we'll go ahead and move forward. Okay, a lot of the same rules apply, naming alkenes as it does alkenes. So we'll just go right in order with these because just out of curiosity, you might say all of them look difficult. Maybe yes, maybe no, but this one is probably the most difficult, this green one. There again, we're going to navigate you through this process. Okay. So what would you envision this compound is called? Because it's got a double bond in there. So we already know the suffix that it's an alkene. The next thing you gotta do is find the parent chain. And what would you envision that we would call this? Okay, and it's just regular pantene. Okay. We don't need to put any numbers in there because there's no derivatives. The double bond is located on the end, or I should say the first one. Depends whether you want to call it the end or the beginning. Okay, either one, probably the beginning makes more sense. And if you really wanted to be specific, you could put 1 pentene on here. Now, what would happen though if we did something, this would be kind of like a low down dirty trick. Okay. Is there any derivative on, let me start over. Is there any alkyl derivatives on the first carbon? An ethyl group, a propyl group, a methyl group? No, because when you put this here, it's part of the parent chain. So this compound would be called what instead? Not just pentene, but rather what would you think? Okay, true. We got 1, 2, 3, 4, 5, 6. Okay, could call that hexene, which is true. We just got to make one tiny addition to that. You need a 2 there, and that is why. Because it's after the second carbon. So that would be 2-hexene then. Okay? So if this was not present, it's pentene or 1-pentene. But if we put that guy up there, we change it to 2-hexene because that double bond is located after that second carbon. Right. So if we understand that one, the one in purple, okay, is one of those that we had discussed yesterday. So this you would envision as being what? I should slow down a little bit. Okay, so we know that it's butene because it's got 4 carbons to it. And the last thing we got to do is just name where that double bond is. And it would be after the second carbon. Okay. Just like this one is after the second carbon, so is this one. So this would be 2-butene. Okay. So the reason I'm putting this box up here will probably help you with this. Okay. Is that you've been evaluated over this. We know this is a ring structure. Okay. And it would be cyclobutane, but these derivatives are on 1 and comma 3, but notice how they are oriented. They're both pointing up. Do we remember what that means? Yes, this would be cis 1 comma 3 cyclobutane. The same logic then is placed upon here. This is also butene, but notice the geometrical shape or difference between the two. Okay. Notice that there's 1 carbon on this, or excuse me, 1 hydrogen on the second one. Okay. Put a 2 here, 2 here. There's that same hydrogen. This one we could say is number 3, and it's got 1 hydrogen, and that is that one. Okay. So what's true about these two CH3s? These are not derivatives as part of the parent chain. Okay. The only difference is the geometrical shape. We know we still got butene. Okay. But just like that ring structure we talked about, those methyl groups were both pointing up. Okay. So does that mean cis or trans in that example. That means cis, that double bond is located after which carbon? 2. So this is what we call cis 2-butene. Okay. I think perhaps, how about we wrap this up? Left outside on the bus. Left middle is a glare on. Left middle, we good? Right middle, right outside. Okay. I think we'll go ahead and pick up with these two. I mean, if you have them wrote down, feel free to take a stab at it, and we'll pick up with that content tomorrow. All right. We'll catch up to you next time.